we already talked about this page in particular. We talked about blocking, and as we did yesterday in our dogs lab, we blocked one trait at a time. And so I wanted to mention to you that in the AP exam, the College Board will not ask you to block by more than one trait at a time unless it asks you to do this thing called, unless it implies it needs you to do matched pairs, which we're going to learn today. So, for example, when we did this problem, when you did problem on page 42, when we did this 2 days ago, we did this, we had smoking and weight can affect the cholesterol level, but I had you take that off. I said do not include smoking because College Board will only ask you to block by one trait. So, now we want to talk about what can you do if you have a ton of things that affect something. So we're either going to have one item that you want to control or we're going to have a bunch of things that you need to control. And that's today's topic on page 41 called matched pairs. So matched pairs is our goal to talk about today. So let's look at that. Matched pairs are essentially twins. Think in terms of matched pairs being twins. In history, it was pretty gruesome in the Holocaust for many reasons, but in particular, if you were a Jewish set of identical twins, Holocaust, okay? So if you were a Jewish twin, then you were not necessarily sent to the concentration camps, especially, identical twins. You were not sent to the concentration camps. You were sent to the science experiment lab, okay? And because you have the exact same traits as your sibling, and so then they would have, randomly assign one of them to one treatment and the other one to the other. And it'd be interesting to do some research on that, but at the same time it'd be, gruesome to do the research on see what experiments they actually performed on them. So, but twins were key people that they did scientific experiments on. Now, by nature of them being twins, oops, I didn't mean to do that. By nature of them being twins, it can only be 2 treatments. We do not have matched triples or matched quadruplets. We have just matched pairs. So we're just going to have, 2 treatments. Okay? Now, matched pairs design is a type of blocked design in which you are trying to control some traits. It's just that with them being matched up, you are controlling a bunch of traits. You are controlling a lot of traits. And so we're going to do an example of how we can, that shows us controlling a lot of traits. Okay. So let's take a look at this problem here. Number 2. Suppose that the experiment using fertilizer on a 20-acre farm described in the previous handout has been redesigned the following way. So let me give you a little background because I don't think we did that problem. In a previous problem, the 20-acre farm was 20 randomly selected acres across a county. So they were just single acres randomly placed across the county. And then they put them in a big bag, or they put their coordinates in a big bag, shook well, and randomly assigned half of them to get the new fertilizer and half of them to get the current fertilizer. And then we are attempting to measure the wheat plant crop yield. Yes. Question.
So, if there's a new fertilizer, isn't it now the current fertilizer?
Yes, it is now the current fertilizer,
So,
and then...
Are they not the same fertilizer?
Nope. So, in fact, here's the new way that they want to design the experiment, because let me ask you this. Are there things that can contribute to crop yield? What kind of things does a farmer have to deal with that contributes to how well is...
Insects.
Insects, good. What else?
Weather.
Weather.
Ground.
Soil quality, soil type, the terrain, the rockiness. So think about across Parker County from here and even south of here up north to past Springtown, all the way west past Weatherford, that kind of stuff. So there's a big variation of terrains and quality, and you got trees in some areas, you got water things in some areas. Okay. So we have a lot of qualities we need to control, a lot of traits, not just one, that we are going to control. Therefore, we're going to get twin acres, okay? So we're going to have 10 2-acre plots of land. So think of them as little pairs of acres across the county. That way, if they're right next to each other, then they're supposedly going to be much closer in all of their qualities. Do you agree? Mm-hmm. One's right next. Okay, so that's what's going to happen. And so one of the first questions we have here, what advantage is there for this method? What will having twin plots of acreage do for us? Reduces variation. It will control, or I love the way you're using that language, reduce the variation in the crop yield traits, or the qualities to get crops, whatever. Okay, awesome. Okay, which ones of the treatments, the current or the new, would be considered your control group? The current. So we are going to consider the control group as your current fertilizer, and then we're going to compare to it the new fertilizer. Okay, so let's move on and talk about how we can design this. So we're actually going to, we've had SRAT cap, that was when we had it completely randomized. We had BRAT cap was for when we had what? Blocking. And so any ideas what this is going to be? MRAT cap. It's going to be the M at the beginning. So we're going to do a matched pairs with MRAT cap. Okay? And this is our third and final design that we are going to learn in this class. So let's go ahead and do that language. Here we go. Guess what the first word is? Good. We are going to match 2-acre plots by similarities in location. And then we can list some of the other things we talked about. Terrain. Because the location will end up creating the location, the terrain, the weather, pollution stuff, the ecosystem. Like, is that all of the animals and stuff on it? I don't know. And insects. Okay, whatever. Okay, your biome. Okay, so we just put several qualities there, and so we are matching those by those similarities because remember when we BRAT cap. So this is really, you know what? I hate to say it, but there really should be the little B in here because it's the because. Match because those traits. What?
Affect yield.
Wheat crop yield. Good job. You were not generic in your statement there. You were specific, so good job. Okay. So now, let's keep going. We're now going to do what? Randomly assign. What are we randomly assigning?
The fields. No. The new fertilizer trees.
Okay, we're going to take, of that 2-acre plot, one of the 2 acres to the new fertilizer. Okay. Fertilizer.
And the other 2 bits.
Do we not need to explain how
Yeah, we're about to. Yeah. And yeah, I should put a by in there somewhere. Okay, hold on. I'm kind of getting out of. I'm putting the T. We're gonna repeat this thing 5 times, or 9 more times. Are you talking about the 10?
Oh, you're doing it by splitting the 10 plots in half.
I'm talking about just one pair of 2 acres. And so we're going to describe, remember how when we did a block design, we described what just happened in the overweight people? So this pair is a block. So I'm going to describe what happens with 1 pair of acres, and then I'm going to say, do this with 9 more pairs of acres.
But you have 4 acres.
Yeah, 4 more pairs.
But it says, no, does it not say 10 2-acre plots?
So she splits each
You're not
Yes.
splitting
and
the
gives
2
one.
acres into one acre. You're just saying.
Yes,
one.
I am.
Oh.
Oh.
She's giving one of the just 2
So I got a 2-acre plot, and so I'm taking one of the 2-acre plots, and then I'm going to split that into 1 and 1.
Oh, okay.
Okay, there we go. Woohoo! Okay, so randomly assign one of the 2 acre take to the new fertilizer, and one, and the other acre. I should just say other acre to the current fertilizer. Okay, do this by, okay, we've had some debate on how to do this in the other classes. Because something strange, I know, I don't mind putting babies in a bag, shaking them, but for some reason, putting acres in a bag just doesn't compute to me because it's dirt. But how about if we put their coordinates in a bag, okay? By putting,
Fields in the back of their names.
yeah, putting the acre coordinates, yes.
Would we have to put like 1/2 acres in one bag, 1/2 in another? Because what if like both sets of, like there's 1 2-acre farm, what if both of those acres ended up being
So you're putting a 1
new
inch in
fertilizer?
twins in a bag.
So I take a,
But then I thought you were
So
randomly
I-
assigning which side got, which acre of the 2 got the fertilizers.
true.
If you put them all in the bag,
So
you
you
could end up with both acres
So that's how
being the new
cereal-
fertilizer, couldn't you?
No, only 2-acre coordinates. 2 coordinates are going in a bag.
Oh,
See?
okay.
Randomly assign
You're not putting
one
all
of the 2 acres to the new fertilizer and the other of the 2 acres to the current fertilizer. Do this by putting the acres, the 2 acres coordinates in a bag, shake well, and pull out 1 acre for each treatment. So we're doing everything in terms of just 1 pair right now. Okay. All right. That's Murat. Now what? Me. Measure each acre's wheat crop yield. Okay.
Yeah.
Good. Okay. Now, you know how the next thing is compare the average? Well, I have to have a lot of numbers to average together. All I have right now is 1 number for the new and 1 number for the current. How do I get more numbers? Yeah. Repeat. Remember within 9 more pairs. Remember how we would say repeat within each block? Repeat with 9 more acre pairs. There we go. So now we've got pairs across the county. In each pair I've got a new, and each pair I've got a current. Okay. So how do I get an average?
You add them up, and then
Yeah, but add what up?
You add the new fertilizer.
Okay, good. So I'm going to go across the county, and I'm going to get the number for all of those 10 that were new, and then I'm going to get the numbers that were for all of those 10 that were the current, and that's how I get my 2 averages.
So you're not doing this one on a scale, you're doing it based off the actual crop yields.
Yes, yeah. So compare the average wheat crop yield of all new fertilizer acres to the average wheat crop yield of all current fertilizer fields. Okay, so does that seem to, acres, I guess, acres, not fields. Okay, good. Do we agree that we understand they were all spread out across the county and they were paired up? Good. Okay, there is two ways to do matched pairs. This is one of the ways, and I need to explain to you the second way. Okay, the second way I'm going to explain to you is on the next page. We did number 3 together last Monday. And so we're going to look at number 4. And although I think there's another way to do this, we're going to do it with the, I'm going to design this with the other matching method just so we can practice that. So here we go. An educational psychologist wants to test 2 different memorization methods to compare the effectiveness to increase memorization skills. There are 120 subjects available ranging in age from 18 to 71. A psychologist is concerned that differences in memorization capacity due to age will mask or confound the differences in the 2 methods. What would the design look like? Honestly, in this description, how many confounding variables do they describe?
1.
They describe 1. So if you just did a straight blocking where you blocked maybe, how might you block?
Age.
Yeah, so you could do like 18 to 35 and 36 to 50 or whatever. You could make chunks of age groups. Okay, you could do that. How could you match pair their ages? Find a pair of people that are what?
18.
Matched closest in age. So out of the 120 subjects, find the pair of people matched closest in age. And then you would describe what happens in each pair and then repeat that in the other pairs. Well, because I want to describe for you another way to do this, I want to do this thing called a crossover design. You don't need to know that it's that name, but you might maybe come across that if somebody ever in another class, psychology or biology or something like that. I'm going to do a matched crossover design, but I don't expect you to know that vocabulary. And what happens with this, here is the key. Each subject is his or her own block. And participates in both treatment groups. Okay, so for example, as a subject in this, I would do method 1, and you would get my score on that test, and then I would do method 2, and you would get my score on that test. Okay? Now, does anybody see a potential problem if all 120 subjects do the method 1 first and then the method 2 second? What might happen?
Well, they could be
Forget
tired of
stuff
memorizing.
too.
Just remember what's on
They
the
could
test.
use a little bit of method 1 in method 2.
Okay, good. They could use a little bit of method 1 in method 2. So by virtue of you doing method 2 second, it could come out better for most people just because it was the second and you were already warmed up and your brain was already, had some strategies. So that's an issue we need to address. So how could we do that?
Wait, or couldn't you also forget?
Beautiful. Okay, hold on a second. We could make half of the patients do method 1 and then method 2. And the other half of the patients would do method 2 and then method 1. So that way the order is not what's defining which one is better done.
Never mind.
Okay, so let's describe how you do that. We're going to Murat me cap. Okay, and so let's try this. So unfortunately the first is about matching, but I don't know how to start it with the word M. I need to say each subject is its own matched pair and will complete both memorization methods. Okay, so that's my first statement.
I have a question.
Yes.
If we had a question like this on the STAR test and it doesn't specify.
Or AP, go ahead.
Or that's what this, AP does. Sorry.
That's okay.
And it doesn't specify like which design they want us to use, we can use. We could have done a block to this.
Yes, this one, truly, since they just really defined one thing, blocking probably would have been more appropriate. But for teaching purposes, I didn't have a good problem to show you this design here, so that's why I'm kind of trying to steer it that way. Okay? All right, so we got to do wrap me cap. So what will I do? Randomly assign. What do I randomly assign? Good. Half of the subjects to complete method 1 first and then method 2. Good. The other half of the subjects complete the methods in opposite order. Or you could say method 2 and then method 1. Okay, now I'm just going to put an asterisk, big bag, and we're just going to save some time and not put that in there, but don't forget that you need to tell how you assign them to those two groups. Okay, so what am I going to measure? Measure each subject's method 1 and method 2 scores, because they took a little test or something. Okay, and then what am I comparing?
Improved memorization.
Average difference in the test scores for them. Okay, so just ... You can word that out. Okay, you get the idea. All right, so that is the crossover design where each patient is his own block. All right, so now in summary, you've learned all the methods. There's completely randomized, blocked, and matched, but I want to go over your homework with you because I'm reducing it. So let's take a look at your homework. Starts on page 43. Here we go. So on page 43, you are going to end up omitting number 2 and number 6, and so let me go over that with you and some other stuff on there. So number 2 is this bottom one that about the full moon on page 43. So omit that one. Okay, now on the next page, page 44, does this format of a problem look familiar?
Yes.
It sure does. So you know you're going to figure out what it is and do half. But I want to point something out to you. Look, if it is an experiment, look at question E, which we have in the past skipped. Guess what it says? Is the design completely randomized, blocked, or matched pairs? Dun, dun, dun. We know that now. So if you do the experiment, you can do that problem now. Yay. Okay, moving on. So here we go. On page 45. This is about breakfast and seeing if you like the new flavor or the original flavor. A new flavor or the original flavor, okay? And it specifically says to design a completely randomized experiment. What does that mean?
No blocking.
No blocking. No blocking. We're just going to do straight, complete randomized, and no matched pairs also. Complete, shake them and put them in a bag, or put them in the treatment groups. Okay, but look at this one. This one says they suspect that some of the children regularly watch a Saturday morning cartoon show starring Frump, the flying teenage warrior rabbit, who eats frumpiness in every episode, and they may respond differently to the new flavor. How would you take that into account in your design? Oh, you will block what? How? Why? What would you block into?
People who watch.
Those that watch and those that don't. Very good. Moving on. Look at number 5. Do cars get better gas mileage with premium instead of regular gasoline? So we're talking gas mileage. What things contribute to gas mileage?
Speed.
Speed. Type of car. Where you drive. How far you drive. The roads you drive on. Oh my gosh. Thing after trait that contribute to this. So we're going to do matched pairs most likely. Don't you see that? So, see, it's becoming more clear to you as you read a situation which one you're going to follow. But look at number 6. This all rest of this page, including the very bottom that you may or to all down here with this, all gone. No more on that. So that is your homework for tonight, pages 43 to 46.
Where'd you do your Friday night?